Hey guys, we need to have a serious talk about the future of Blender. Right, just kidding, the future looks really cool. This video is about geometry nodes and the future of geometry nodes. The wonderful people at Blender just decided on a new sort of way of creating geometry nodes, node trees for the future. So what I'm going to show you today is very experimental, and it's just like there's a prototype build where you can try this stuff out with just a few demo nodes. So this is very unstable, it keeps crashing all the time. But we can look at sort of what's fundamentally different to the way that we work now with geometry nodes. If you're interested in that, stick around. We'll jump right into Blender and look at it quick. Alright, I have two Blender versions open so we can look at the old and the new way. This is going to be the new one, the one with the green background. And then I also have the old one here, and I set this up to have a white background, and we're gonna do a donut tutorial. Well, it's a donut demonstration, or we're using a donut for demonstration purposes. And that's exactly what they use for the example. I'm gonna link to that, by the way, down below so you can read up a little about the two types that were proposed. And then they made like demo implementations for both, and then they decided to go with one of them, and they called it fields. So whenever you hear fields in combination with geometry nodes in the future, basically this is the way to do geometry nodes coming to Blender probably 3. So I have Blender Launcher, and if you want to try out different versions of Blender, Blender Launcher is awesome because you can go to the experimental, can go to downloads, and you see all the experimental builds that are available. Then you just hit download. Then it shows up in your library over here, and you can see this is the one with fields. And you just click launch. You can see I have one running. And then from the daily builds here, I downloaded the 3.0 alpha from August 13th, and I have one running. So I think we should start by trying out and maybe making some frosting. And we're gonna do it in the old version, the old way with the attributes. And then we're just gonna jump over to the new way and do the whole donut in the new system, right? So this is the old way. How would we go about this? First we need a node tree. And then how do we pick out just the top vertices where we want the frosting? Okay, so we want to sort of move the top vertices out a little. We're gonna need the normal, and the normals that have a C value that is positive are the ones on the top of the donut. Okay, so attribute, we're going to separate XYZ. We're gonna take the normal and we're gonna separate that out in, just take the C. And then we need in attribute math, if it's greater, if the C is greater than or float 0, then we call this mask. That will be the mask for the frosting. Okay, so if C is greater than 0, and then we need a vector attribute vector math, and we need to multiply our normal with that mask and put that into something new like an N. And then we need to do another vector. Oops. We need to do another vector multiply. No, we need an add. We want to add to the position of the vertex our N and plug that back into the position. Okay, it's already doing something. Cool. Now this is way too much, obviously. First of all, you know what? I'm gonna go into edit mode and subdivide just once so we have a little bit more resolution on our donut. Okay, so this is way too strong. So in front here, we are going to do a vector multiply. So let's just copy this one. And we're gonna multiply the normal with a vector and put that into the N. And then over here, instead of normal, we're gonna use that N. here too. And now we have a factor here where we can say how much do we want the frosting, how much bigger should the frosting be than the donut. So all of this is just to create like a little bit of an extrusion, right? And when you look at the node tree, you can't tell what's happening. You have to start at the beginning. You have to think like a computer. Okay, we're gonna take the normal, multiply that. When we use n, n then goes from here into here. We're gonna take c and multiply that, or figure out which one is going pointing up, and that's our mask. And then we take our n from here and our mask, and we multiply that. So we only selecting out the top ones, and then we add n to our position, which means we're just basically pushing it out on the normal, because that's the n is the normal. And then we have this. So this is like super complicated. I personally think the node tree is like not readable at all. And I've said this before in other videos. So enough of that. Let's see what the new geometry nodes bring. I'm gonna go in here as well and give us a little bit more. Oh, you know what? Should have done that with smooth. So we have smooth subdivisions. Okay, here we have the donut. Now, how does this new thing work? Well, when you think of node trees, you definitely first think of shader node trees. And in shader node trees, we have all different types. They have different colors. You can create very nice looking node trees based on the object that the material is on as an input. So we don't even have this input node for shader nodes, right? Now, the new way of doing this is exactly the same. No, it's almost exactly the same. Let me show you. First of all, there is a node in here that is the extrude node. Mesh extrude. Now look at that. That's a new node. And you can see we still have geometry in, geometry out. And then we have this thing here, top faces, side faces, and we have selection. And then we have the distance, which is just the distance of the extrusion. So what can we plug into selection? Well, we want the part where the normal points up. That's what we did before. And that's what we can do here again. So how do we get the normal? Well, and this is where it starts to be completely different. And I don't know where I can find these nodes yet. Input. Here it is. Input face normal, right? So this is a node. You can see we're not plugging in the geometry. This is a node just like the geometry node in shader node trees. Let's just go over to shader node trees. Pick this in the back there. Here we have texture coordinates. And here we have a normal output. And this is the texture coordinates node for the object that this material is on. Now here we have face normals for the face normals that this geometry nodes modifier is on. Cool. So we don't have this super long like line of nodes just to get the normals and multiply and do stuff with it. This is just, it's an input node, the face normals for this object. So, of course, then we need to separate XYZ. XYZ, we take the C and plug it into selection. So now what does that do? So selection is sort of like true or false, or 0 and 1. And everything other than 0 is basically true. So if the C, or greater than 0, is true. So if the C is pointing downwards, it's false. 0 is still false, and as soon as the C is pointing up, it's true. And this is our selection. And then with the extrude node, we can extrude this selection with some distance. So this is exactly... Now look at how much nicer this node tree looks already. And this is all we did with the other node tree. All of this is necessary to do just that. And this makes much more sense. Take the face normal. We don't need to find the normal attribute and do stuff with it. And we have our frosting. Now what can we do with this? So this extrude node gives us top faces and side faces. Now when you think of it, let's go back to 3D view quick. Put in a plane, put that up here just for demonstration purposes. Insert it maybe a little bit. If I hit E and pull this up, now this up here, this would be the top face, this, and then these new faces going around here, these would be the side faces. Let me get rid of this, and let's just delete this object again. We had shader nodes up here, and here we have the donut. So top faces, side faces. Now let's do something with that. How about we add some noise to the frosting part? So to the top, maybe just the top faces. How do you add noise in the shader nodes? And forget about how you would add noise with the attributes and like, I don't know, a cloud texture or something. You just add a noise texture node, right? Now, I'm sure this is going to change and we're going to have all sorts of textures, image textures and all that. But for now, we just have one noise texture node in the utilities. And look at this. We already know what this node is because looks just like, for example, the brick texture node of the shader editor. And here now we have noise textures. And I think we will be able to plug in like UV maps and stuff. But now we have a noise texture. So we just want to point translate, right? Point translate. Point, which would be the vertices of our geometry. So we're plugging into geometry. Which ones? Well, we just want the top faces. And we want them translated with this color, like color RGB, vector XYZ. You can plug a color into a vector. And now, if we do this for our output, now we're actually putting a noise onto just the top part of our donut. Okay, this is a bit much. So what would you do with shader nodes? You would put in a math node. You would you need a vector math node. Vector math node. Plug the color in here. Multiply that by some factor and use that for the translate. Now we have a noise texture on the frosting part, on just the top faces selection. We have the scale here of the noise texture, so we can bring that down a little. We can play with the detail, we can play with the roughness, we can play with this value here. Oh, by the way, I don't think I want X and, I don't think I want X and Y, I just want some noise on the C. Or maybe this is even too much. So let's bring that down a little. I don't know. Yeah, you get the point. Now we have noise texture on the frosting. How can we make this look nice? Whatever. But of course it doesn't look like frosting. So how can we give it a new material? Well, we need a new material first of all. Let's just give it a new material, call it frosting, just so we know which one to pick. Make it pink. Now this is not assigned to anything yet, that's why it's still all brown. But of course we can do a material assign node. So to the vertices we're assigning the frosting material to the top faces. Now this looks weird because these faces need to be added too. They also need to be the frosting material, right? So how do we do that? Well, this is Boolean. You can think of true or false or 0 or 1, whatever. What's the logical thing to do? You add top faces and side faces together. So math, add top faces, side faces, and now the side faces here are also pink, right? Just the top, and side. So this is really, really cool and really easy to read, I think. I love it. It's awesome. So this distance is probably a bit much, so let's bring this in. And now for the sprinkles. Oh, first of all, we need to shade everything smooth, right? And the frosting needs to be more shiny. Cool. I just saved the file, so because, like I said, it crashes a lot. So now let's put on some sprinkles. Well, for sprinkles, we're gonna need a point distribute, right? So we have to change, or we have to do something with our geometry. We need to distribute points onto the geometry, and when I do that, everything disappears. Why? Because we're replacing our entire geometry with points now. So here are the points. We don't want that. We want to combine this geometry, which is the donut with the frosting, and the points. Do we have node wrangler? Yes, we do. So we can combine, join geometry, the donut, and the, I don't want this point here, and the sprinkles. Now we need to point instance. We need to instance a sprinkle onto these locations. So first of all, we need to create a sprinkles. So we take a cylinder, scale C4 maybe. Does that look like a sprinkle? And then we go back here. We instance this cylinder, but it's of course very big. So let's bring it down. Now we have sprinkles. There are not that many sprinkles, huh? We need to increase our density. And they're all facing the same way, so we want to rotate them randomly. And we can do that by using utils. Input random float. Take the ID of the point distribute, plug that into the rotation, -5 to +5, and we have sprinkles. But we have sprinkles on the bottom. That doesn't look good at all. We only want to point distribute where we have probably just on the top faces, right? So let's just put the top faces into the density. Remember, 0, 1, false, true. And now we have sprinkles only on the top faces, none on the dough part. But since I plugged that in here, I got rid of my density value. So what do you do in any other node tree in Blender? Again, you need a utilities math node. You need to multiply your density, which is just 0 or 1, by something like 80, and you have sprinkles. Now you just give it some colors, and there you go. That is the new way of creating geometry nodes, node trees. Here we're using the face normals as an input, and we're not piping in our geometry and then getting the normals attribute out of that. Right, so I played around with this. By the way, I love it. I think this is awesome. This is exactly what geometry nodes needs, because I don't like this at all. Everything looks the same. It's basically just one line. It's not a node tree. It just goes geometry, geometry, geometry. This is much better. I think it's much better. But of course, now there's some things that we have to consider. First of all, these geometry nodes, or these geometry lines, going from the input through all the way to the output here, these are sort of a separate thing now, right? You have two sorts of lines or noodles now in your node tree. You have the geometry, which is vertices going through, and then you have all the other stuff. So I would actually propose that these lines are probably that same green as the geometry sockets, so that you know these are geometry lines going through, and then all the other lines are just like in all the other node trees. They are for attributes and fields and just values, vectors, booleans, whatever. So that would be, I think that would actually be good for usability or user experience in this case. And then there's one other thing that I've found out while playing around. So what if we want to subdivide this donut a little bit more? Well, we could just go in here. First of all, let me save again. First, we can go in here and we can do mesh subdivision surface. So we have a node. Now what happens if I plug that in here? Look at this. This is what happens. Why? Well, because this input, if you think of it as being an input just like the mesh or geometry input, you have the face normal input. This input is based on this incoming geometry. And now we're subdividing the incoming geometry, but we're not subdividing the geometry that the face normals are based on. And that's why we get this. So we're just extruding the geometry, but based on normals which are not subdivided. So this doesn't work. We have to get rid of this. However, back here, where we're using the input geometry and the input normals, if we get a subdivision surface node and we plug it in here, now we have a lot more. So we have very fine geometry now. Back here, it works just fine because we're using the geometry, the normals based on that geometry. We're doing something with it, and then we can subdivide. All right, I think this video is already long enough. This is supposed to be just a first quick look at what is coming to geometry nodes. I like it. Let me know if you like it. Down in the comments, just write a hell yeah or no way or whatever. I'm looking forward to your replies. Thanks for watching. Chris P out.